before starting solid state, let me tell you what will be the pattern for this session, this whole session. So every week, we are planning to have 2 sessions of 1.5 hours. Okay, of 1.5 hours, there will be 2 classes of 1.5 hours, and as per need, we will have 1 hour class in which we will be doing problems, doubts. Okay, and if you don't have problems and doubts, then we will be doing theory only. Okay, so here we also again we have 4 hours in every week. We have 4 hours in every week. Okay, now this 1 hour will be as per need with problems and doubts of theory. Okay, we will start with 1.5 hour, 1.5 hour. Then after each of these classes, you will get assignment. Okay, and if there is 1 hour class, then after that also you will get assignment. With each class, you will get some assignment, and there is weekly test that you already know of. Okay, there is weekly test. Okay, none of you are new students here. You already know what is the pattern. Now the new thing is that you will get study package this year. Okay, you will get study packages this year. You will get study packages this year. Okay, now this 1 hour class here, everyone has to attend this 1 hour class. Okay, it is not like if you have problems or doubts, then only you will attend. You have to attend this 1 hour class wherever it is. Okay, whenever it is present. And these 1.5 hour class will be regular classes. Okay, regular classes. Okay, now study package, it will be like it will be online, mostly in PDF form. Okay, mostly in PDF form. Anything that you want to ask about these parts? Weekly
Sir,
assignment
the
test?
1 hour
No.
class, it will be like an extra class?
No, it will not be an extra class.
Okay.
Okay, it's not. You have to attend whenever there is 1 hour class. आप लोग की schedule से ही पूछ के लिया जाएगा for that 1 hour class. Okay, it is not an extra class that you have any option. Okay, so before starting solid state, I things that you know about a cube. Okay, because cube is a particular pattern that you will often see in this chapter. So I want you to revise a few things about cube that you already know. Okay, I've got a chat. No, Shravya, not on the same days. There will be some changes. Okay, and that Nishkar sir will tell you about those changes. Okay. So you can see that I'm making a cube. Take it from here. Similarly, I will make one line here. Yep. Now you will answer me easy questions. Okay. Just send me in chat how many corners are there in a cube. How many corners are there? Write in chat how many corners. Correct, Atif? Correct, Khalid, correct, Shravya, correct, Salman. Waiting for Maimuna. Yes, correct, Maimuna. Okay. So there are 8 corners. Now tell me how many edges are there? How many edges? No, Salman, wrong. Okay. Yes, Atif, correct. Yes, Khalid, correct. Sharavia, correct. Maimuna, correct. Okay. Yes, Salman, now you are correct. And how many faces? How many faces are there? Correct, Maimuna. Correct. Atif, Shravya, Salman, Khalid. Okay, fine. Everyone has answered. There are 6 faces. Now you guys tell me how many diagonals are there? How many diagonals? Okay, Maimuna. One new question and you start thinking, okay? It's not like, sir, nahi pata. Ye mat boliyega. Start thinking about it, okay? This whole chapter is about imagination, okay? And I will make you guys imagine things about, mainly you have to look at your room and see things, okay? You have to look at your room and see things. Okay, Shravya is saying some answer. I will ask you, how are you saying? And first of all, okay, Atif, everyone is giving me question marks. Okay, so if somebody is giving me some number, I hope they can see those diagonals, right? Atif, Shravya, and Maimuna, you 3 have given the answer.
Yes, sir.
Right? So you can see them at least. Okay. What about you, Atif? You can see them. Whatever you have said 8, so you can see 8 diagonals. Yes or no? At
Yes,
least. Okay. Maimuna has written 2. So Maimuna, I hope you can see 2 diagonals somewhere.
Yes.
Okay. Khalid is giving me answer 12. So I think Khalid can also see 12 diagonals. Okay, fine. Let's start with Maimuna. So Maimuna, I think your room must be somewhat cuboidal, right? Of cuboid shape. So we can approximate it to a cube. And let us say that this is the front wall. Okay, this is the front wall. This and this. Okay, front wall is this one. I hope you can see that. This wall is front wall. Okay, fine. Maimuna? Yes or no? Maimuna, is this fine? This is the front wall. Can you hear me? Maimuna, I can't hear you. Please say yes or no. Okay, what about others? Can all of you hear me? What happened?
Yes, sir.
I'm audible
Hello,
now.
sir.
Yeah.
Can you hear me?
Maimuna. Yeah, I can hear you now. Yes. So I'm asking you to see that this is the front wall, okay?
Yes.
So now you tell me, where are the 2 diagonals?
One is in the front and the other is at the back.
Okay, like this. You're saying these are the 2 diagonals?
Yeah, I guess.
Okay. Okay, then we can have more diagonals now, like this also. Yes or no? On each face.
Yeah.
So, okay, fine. Now I want to ask Shravya. She said 16. Yes, Shravya.
Yes, sir.
How 16? Can you explain me? I can see 12 at least. Then those are the face diagonals. There are 6 faces, and on each face we have 2 diagonals. So there will be 12 face diagonals. So I mean, what are the other 4 diagonals that you have? Where do you see those 4 diagonals? Tell me. So this is one face, and this one face has 2 diagonals.
So could you repeat again?
You said how many diagonals? What was your answer?
So 16.
16. Okay. So tell me, where are those 16 diagonals?
So like considering the faces, those diagonals, and the rest of the spaces are there in between. So I consider those. I mean, I consider my room. So accordingly, I saw.
Accordingly, so I can see 12 like on the faces, right?
Yes,
Where
sir.
are the rest 4?
Yeah.
Rest 4. Where are the rest 4?
Joining the middle, this one. I don't know how to say, but then
Okay, I'm taking a face like this face here. Okay, this face
yes,
I'm
sir.
taking. This face now. When I see a diagonal, you can define diagonal as line joining
Yes, sir, both the corners.
two opposite corners, not both the corners, two opposite
I
corners,
mean,
right?
two opposite corners.
Yeah, two opposite corners. Okay, fine. So I will number them, or rather, I should just name them like this: 1, 2, 3, 4. You have 5, 6, 7, 8. So you tell me which are the two corners that you want me to join.
So we can join 4, 6, 3, 5,
4,
then
6,
1,
no,
7.
4, 6, 3, 5 is already done, na? Because it is face diagonal, right? 4 and 6 are
Yes,
in the
sir.
face. So we are done with those. What else can we join? Now I think other people can also answer two opposite corners, okay? But they should not be face ones. They should not be opposite in the face, okay? So maybe try. What is opposite? Anything which is not adjacent, it is opposite, okay? Something is not adjacent, it is opposite. Okay, fine. Salman, very good. So
should we raise the answer in the chat?
you can write the answer in chat for sure.
Okay,
Yes, Shravya, correct. Now you guys can see, right? Now you guys are able to see. Okay, yes, correct, Shravya. Oh, bhai sahab. Khalid, tell me what are the corners that I have to join? What are the corners that I have to join? Yeah, I have numbered the corners now. So if I talk about the face diagonals, the face diagonal is done. That is 1, 3. We'll make a face diagonal. And what else? 2, 4. We'll make a face diagonal. What else? 2, 6. Make a face diagonal. 3, 7 will make a face diagonal. What else will make a face diagonal? 4, 6 will make a face diagonal. 3, 5 will make a face diagonal. What else will make 8, 4? 1, 5. 1, 7. And 2, 8. I think these are the 12. 3, 3, 3, and 2 more. Okay, fine. I think 8, 5, 7, and 8, 6. Okay, so these are the face diagonals. You don't have to answer these. What are the other diagonals that you can see? So Atif has said 1, 6. Yeah, correct. 4, 4, 7. Yes, correct. Okay, fine. So this is the best diagonal that I can see. Okay. And also 2, 5 is also a good one. No, I will draw 2, 5. That makes it more easy to see. This 2, 5, right? Now this is a body diagonal. This red one is a body diagonal. And then I will make a green one, which is a face diagonal. So 5, 7, this is a face diagonal. Okay, it's a face diagonal. Now, so how many face diagonals are there? So diagonals can be of two types in a cube. It can be either a face diagonal or it can be a body diagonal. So how many face diagonals are there? There are 12 face diagonals. And how many body diagonals are there? There are 4 body diagonals, right? And you can also see that there are 8 corners in a cube. And for one diagonal, we need 2 corners. So 8 corners will give me 4 body diagonals. Okay, it will give me 4 body diagonals, right? And face diagonal is something about the faces. So in each face we have 4 corners, and we need 2 corners for one diagonal. That is why we have 2 diagonals in each face. We have 6 faces. That is why 12 face diagonals. Now this much is clear with all of you. Now I have to talk about the length of these diagonals. So if I say that the side length is A. Now I'm erasing these numbers. All of you can see now? Yes or no? Tell me.
Yes, sir.
Maimuna,
Yes, sir.
Yes, sir.
right? Okay, fine. So now you want to talk about the side length A. If this is A, this will also be A because it is a cube. What will be the edge length of, what will be the length of the face diagonal? Pythagoras theorem, yes or no? Right, guys? Pythagoras theorem,
Yes,
no?
sir.
So someone is answering. Yes, Khalid, correct. Okay. So here we have the length of face diagonal. So I will say that the face diagonal square, it is equal to face diagonal square, it is equal to A square plus A square. So the face diagonal will be equal to 2A square. And I will root it over. So face diagonal, it is equal to A root 2, right? It will be A root 2. So we have got this face diagonal, which is equal to A root 2. Now, what about the body diagonal? What about the body diagonal? If you see the body diagonal, then you must see that this green line, it is in the floor, right? It is in the floor. And what will be this angle? This angle will also be 90 degrees, yes or no? Because this one edge is coming from a wall. It is between two walls. So this wall will be 90 degrees to the floor, yes or no? You all can see that it is 90 degrees,
Yes, sir.
right? So this will also be A, right? This edge length is A, and this base is what? Base is A root 2, and the perpendicular is our what? Is our hypotenuse. Sorry, perpendicular is A, and this hypotenuse is the body diagonal. So body diagonal square, this will be equal to A square, that is the edge length of the perpendicular, and the base is A root 2 whole square. So this will be equal to A square plus, this will be 2A square, this will be 3A square, and if I write body diagonal, this will be A root 3. Okay, so these are the new information that you have to memorize about a cube. That edges are 12, faces are 6, corners are 8, face diagonals are 12, body diagonals are 4. Each face diagonal has the length of A root 2, and the body diagonal has the length of A root 3. Okay, A root 2 and A root 3. So these are the two new information that you have to memorize. Okay, so you will now copy this down about a cube. So I talk about this cube initially because you can refer it back whenever we need it, and we are going to need this and these information very much, especially these things, the edge lengths.
Sir.
Just raise your hand if you're done. Okay, Shravya is done, waiting for others. Khalid is done, waiting for Atif, Maimuna, and Salman. Salman is done, Atif and Maimuna. Okay, everyone is done. Fine. Now you guys tell me in chat, what do you think is the shape of an atom? Because when I join many atoms, I will get a solid. Yes or no? If I join them very closely, if I join the atoms very closely, I will get a solid, correct? Yes or no, guys? Tell me. Right? If
Yes,
I
sir.
join the solid atoms. So what do you think? What is the shape of an atom? Tell me in chat. Okay, all of you write in chat. What do you think about the shape of an atom? What it is? What is the shape of an atom? It is cube, cuboid, or what it is? Okay, Shravya. Or is it cylindrical shape? Think and tell me, or maybe remember and tell me.
Could you repeat the
Hmm.
question?
What do you think is the shape of an atom? What do you think is the shape of an atom? Yes, Shravya, I think, yeah. We assume it to be that. Yeah, correct. No, no, it is not based on orbitals. Orbitals are, when we talk about orbitals, we talk about where the electron is, not the shape, okay? So shape of atom, what do you think? Yeah, correct, correct, correct. It will be spherical, right? It will be spherical. Okay. Aisha. Hello, Assalamu alaikum, Aisha. How are you? Miss Aisha, am I audible? No, I can't hear you, Aisha. Yeah. And by the way, you guys are right. It will be spherical in shape. It will be spherical in shape. Aisha, can you hear me? Can't hear you. No? Yes? Nothing?
Yes, sir.
Yes, okay. You are here for which class and which teacher?
12th
12th. Okay. Which subject?
chemistry.
Chemistry. And at what time were you supposed to come?
7:30.
7:30. Okay. Where are you right now?
UAE.
In UAE. Oh, okay. Okay, fine, fine, fine. So I think there is it is 7:30 in UAE right now.
Yes, sir.
Oh, so I think you got the Bahrain time or something. Khair. We have not covered much. We were just talking about like the 11th standard. How was it? And we just talked something about the cube. Okay. We are talking about solid state, and you're new here, right? Did you have any classes till now, or is this your first class?
No, this is my first class.
Your first class. Okay, fine. So just a small introduction. My name is Salim, as you can see in the chat, and I will tell you about the format of how our weekly classes go on. So we'll have 1.5 hour lectures. Okay, 2 lectures, 1.5 hour, and one lecture will be of 1 hour. And in that one lecture, we'll more focus on problems and doubts, and there will be more talking from your side than from my side. And in these 1.5 hours, there will be more talk from my side, and you will be just answering me yes sir, no sir, and whatever question I ask. And after each of these lectures, and including the 1 hour lecture, you will get an assignment. Is this clear till now, Aisha?
Yes, sir.
How many 1.5 hour lectures will be there in each week?
2.
2. And what we will be doing in the 1 hour lecture? Most probably,
You will be teaching.
I will be teaching always, but we'll be doing problems. Okay.
Yes, sir.
Okay. And each week you will have a test. There is weekly test that is most probably on Sundays. And for this test and assignment, you have to register yourself in the Learnivio app or the website. Okay. And furthermore, you will get some study packages that will be online in PDF version. Okay. So you can take printout of whatever you like and you can read them. So anything, you are in contact with Nishkash sir or anybody else? Aisha, are you in contact with anyone from Learnivio?
Yes, yes, sir.
Okay, so there is a one WhatsApp number that you are in contact with.
Yes, sir.
Okay, fine. So if you have any queries now, like about the assignment नहीं मिला आपको, or you did not get the link for the test, or you don't know how to register yourself over the app or how to register yourself over the website, then you will ask on that number only. Is that fine, Aisha?
Yes, sir.
Okay. Now you tell me, which school are you from in UAE?
Abu Dhabi Indian School.
Abu Dhabi Indian School. Okay, fine. That's good. And where are you originally from?
Mumbai, Maharashtra.
Mumbai. Where in Mumbai?
Mumbai Central.
Mumbai Central. Okay. Mumbai Central is also near Dadar. Okay, fine. When was the last time you were in Mumbai?
December.
This year, like last year only.
Yeah.
Oh, okay. That's great. So my master's is from Mumbai. There is a college, I don't know whether you will know, but your dad must know by this name UDCT. And now it is named as ICT, Institute of Chemical Technology. Right now I am in Triple IT Hyderabad, and I have a fellowship there. Okay, that's it about me. If you want to ask something else, you can ask me later. But tell me about your chemistry in 11th standard. How was it? What do you think of chemistry till now? Aisha,
It was fine.
that's fine. Okay, the
Yeah.
result is out?
No, not yet.
Not yet. Okay, okay, fine. Okay, so what is going on? Like school is started or school is going to start? What's the scene?
We had bridge classes and spring break started like yesterday.
Okay, a spring break. So how long is the spring break?
Till 11
Of April.
April. Yeah.
Okay, okay, fine, fine. So you did not have any classes till now, right?
We almost completed the first chapter.
Solid state?
Yes, sir.
Okay.
No.
Okay.
Haloalkanes and halogenes.
कोई नहीं करता solid state. Okay, I don't know why is this. Okay, so you have done with haloalkane and haloarenes. Okay, fine. Achha, one more thing is that I wanted to add. We are doing solid state right now, but in the assignments now, I will give in each assignment, I will give one organic chemistry question. Okay.
Yes, sir.
Even if we are doing solid state or we are doing solution or we are doing anything else, I will give you one organic chemistry question, and that will be based on not 12th standard, but it will be based on 11th standard. Okay, like simple IUPAC nomenclature. I will be asking something about resonance. I will be asking something about hyperconjugation, inductive effect, mesomeric effects, the relative stability of carbocations, relative stability of carbon ions. Okay, so these type of questions I will be asking. Electron donating effect, withdrawing effect, these things. Okay, simple organic chemistry, so that you don't lose touch with the organic chemistry part. Here. So now we are done with a few parts about the solid state. Okay, and also all of these sessions, these get recorded, they are uploaded to YouTube. You can access them anytime. If you want a specific lecture, then just tell the date to that contact number that you have of Learnivio, and they will send you the link, and they will send you the link. Okay, now starting with solid state, I was asking everyone, what do you think is the shape of an atom? So the shape of an atom is, we assume it to be the most accurate approximation is that it is spherical. It is spherical. That is something that we can also imagine, and we can do all kind of chemistry approximating the shape of an atom to be spherical. What will happen if I stack a lot of spherical footballs? What do you think? What will happen if I stack a lot of footballs in a room? Will there be any vacant spaces, or it will be completely filled? Tell me.
Completely filled.
It will be completely filled. There will be no vacant spaces.
No.
No,
There will be small spaces in between.
I mean, there'll be minute spaces.
there will be some spaces, right? All of you agree with this? Aisha, tell me. You agree with this? Yes or no?
Yes, sir.
There will be some spaces left, right? Now, inside a solid, there is something which is not solid, correct? Inside a solid, there is something which it is vacant. Nothing is there. So what we will do, like how we prove that root 2 is irrational, we assume that it is rational. So we started with the opposite thing. So when we are going to study about solids, we will start with studying the empty spaces inside the solid, so that we know what is not a solid, and then we can create a solid. Then we can create and start talking about solid. So first of all, we will talk about these empty spaces. Okay, these empty spaces inside a solid, and these are known as voids. Okay, these are known as voids. So the first thing that you know is what is a void. What is a void? Are the empty spaces inside a solid. Okay, aka Aisha, what is aka? Aisha, what is aka?
Also known as.
Very good. Also known as interstitial sites. Interstitial interstitial sites. Okay, what is a void? Voids are empty spaces inside a solid, aka also known as interstitial sites. Now, you all have said that atom is spherical, atom is 3D. Our whole world, complete world, most of the things that we deal with is 3D. It is 3D. But in order to study about 3D, we have to start with 2D. Then we will build upon 2D to make 3D structures, to make 3D solids. This is how you have also studied about shapes. We started with square, rhombus, quadrilateral, these things. And then we further move on to cube, cuboid, and cylinders and cones, etc. So we'll start with 2D. So when we talk about voids, I will introduce two different types of voids. I will introduce 2D void and 3D voids. Okay, 2D voids and 3D voids. Do you know Marathi, Aisha?
No, sir.
Like nothing?
I can understand.
Okay, so what is Kaijala? Kaijala. I don't know how
What happened?
this is. Am I pronouncing it properly? What happened? Yes, correct. And I just picked a very few terms. Ikade. Ikade means here, no? Right? Ikade means here.
Sorry, sir.
Ikade. Like
I'm
come
not
here.
sure.
You're not sure. Okay. So like your family is originally from Mumbai or they're from somewhere else?
Yeah, originally from Mumbai.
Mumbai only. Okay. So now starting with 2D voids, I will make a 2D void. Okay. So also one more thing before starting 2D voids. Wait a second. Okay. Ikade in Kannada also means. Okay. Ikade means Kannada also. Here. Okay. It may have borrowed something from Kannada because it is near only. Okay. So I have drawn a shape. What it is? What is this shape that I am drawing here? Tell me.
Circle.
Circle. Right? It is a circle. Okay, and if I draw, okay, now what is this? What is this shape?
Circle.
Sphere.
Yeah. Okay, so this is about context. When I draw I can only draw a circle, right? In my screen, I can only draw a circle. I don't have any choice. So if I draw a circle in the context of 2D things, then it is a circle. But if I draw a circle in the context of 3D things, then it is a sphere. Will all of you keep that in mind? Okay. So this guy here, it is a circle. And this is here a sphere. Okay. Now, when you imagine about a circle, you don't imagine a ring, rather you imagine a coin. When you are imagining about a sphere, you imagine a football. Okay. So coins and footballs. Okay. So this whole chapter is about imagination. I will try to get you imagine a few things. And now you see, I am taking 3 coins. Okay. So I have taken 3 coins like this. First coin, this is the second coin. And I'm placing it in a certain way to make a void. Okay, so I have made. Can all of you see the empty space? Yes or no, tell me. All of you can
Yes,
see the
sir.
empty space,
Yes,
right?
sir.
This is the empty space, right? This is the empty space. So this is my atom. And this is my void. So first thing is that you identify the void. Okay, where is the void? Okay, fine. I have seen the void now. Next thing is that we have to name the void. Okay, we have to name the void. So for naming the void, what do? We start with the midpoint of atom. What do? We start with what? We start with the midpoint of atoms. Midpoints of what? Atoms that are making the void. Okay, and you join them. And if you join them, tell me what is the shape that is coming out? Just tell me what is the shape?
Triangle.
Triangle.
Triangle, right? So I will name this as triangular void. Easy?
Yes, sir.
Easy, right? Now, next thing about a void. First thing is that you have to see the void, identify the void, name the void. Next thing is the coordination number. There's a term which is known as coordination number. Okay. Now, you must have heard this word that coordinate with your friends, coordinate with your colleagues, coordinate with your cousins to do something, right? You have heard this word in this context, coordinate with someone, get the work done. Yes or no?
Yes.
Yes, sir.
Right?
Yes, sir.
Okay. So, whenever you hear this word coordination in chemistry in this chapter, you will think in terms of touch. If you are in touch with many people, then you can coordinate with them, you can do something. Okay. So the touch is the main thing. So when I talk about coordination number of void, I'm talking about coordination number of void, then I am asking how many atoms is this void touching? This void is in touch with how many atoms? So what do you think? This void, the red thing, is touching how many atoms?
3.
3.
3 atoms.
3 atoms, right? 3 atoms. And by the way we define void, the coordination number of void will always be equal to the number of atoms that make the void, right? That make the void. And in this case, the coordination number is what? Coordination number in triangular void is 3. Is everything clear about triangular void till now? Yes or no?
Yes, sir.
Yes.
Okay, fine. Now the next void that I am going to draw, and you will tell me the coordination number, because I know the coordination number is going to be easy for this one. And you can think about the shape. Okay, you can think about the shape. You can identify shape, but giving the shape a name may be a bit difficult for you guys. But you can try always. Not always try. So I've made a void. These are coins, and by coin I have made a void. I hope you all can see this void. This is the void here. So in the chat, tell me what is the coordination number. What is the coordination number of this void? Correct. Shravya, there is 4. 4 is the coordination number. There are not 4 voids. I think you wrote it something.
Yes, sir. Coordination number.
Coordination number of the void is, so coordination number of void is equal to 4. So all of you have said square void. Yeah, you are somewhat correct. It is square planar void. Okay. Square planar void. The coordination number of this void is what? It is equal to 4. And you can see that if I join the midpoints of the atoms that make the void, it will make a square. It will make up a square. Okay. So these are the two things. These are the two voids in 2D and in 3D. Now let us start with 3D voids. So in 3D voids, first of all, what I will do now, whatever I'm going to draw, these circles are footballs. Okay, these circles are footballs. So I have drawn one football here, and then let me just copy paste this thing. Okay, the second football is here, and I have placed these 3 footballs like this. All of you can imagine till here, yes or no? Please tell me. 3 footballs on the floor. 3 footballs are on the floor. Yes or no? Touching each other.
Yes.
Okay. Now, next thing that I do is I place a football on top of them, on top of all of these 3 like this. Okay. Now, all of you can imagine this. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. Let me see if I get some image. Ball, tetrahedral. Not right now. Okay, fine. Now, let me take the midpoints. Okay, let me take the midpoints. So let me do one thing. Just a small change. Okay, just a small change. What I did is I'm just, for sake of easiness for me, I'll draw this 3 here, and I will place them like this. Okay. So the red one is at the top. Let me first of all make the red one here in the top. Then below we have 3 atoms like this. Okay. So if I join all of them, if you know this shape, this is tetrahedral shape. Yes or no? Tell me. If you
Yes.
don't remember it like this, then you can
Yes, sir.
see it like this. I think most of the people, they will be recognizing this shape as the tetrahedral void. Sorry, tetrahedral shape. Yes or no? This is tetrahedral, right?
Yes, sir.
All of you can see this now. This is tetrahedral. Okay. So this name will be tetrahedral void. Okay, what will be the coordination number? What will be the coordination number?
4.
Very good. This will be equal to 4. Yes, correct, 4. Now let us make one more void and you will name it. We took so 4 footballs like this. Okay. And similarly, we have added 4 footballs on top of them. Okay. 4 footballs, just labeling it red, just decreasing the size so that you can see it better. Okay, so we have in the lower layer, we have the black ones like this. Okay. And on the top, we have the red ones above the black. So just above this black, we have this red. 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 And if I join all of them, then you may see a shape coming up. And what is this shape, guys? Cube, right? Yes or no?
Void.
I mean, it will be cube.
Okay. Yes, sir. Cube.
है ना? Cube. It will be cube. वो मेरे ऐसे बनाने से लग रहा है cuboid, but it will be cube. I hope all of you can see that it is a cubical void. Yes or no?
Yes, sir.
All of you can see that, right? And what will be the coordination number for this one? Tell me in chat. Write in chat what will be the coordination number. Yes. Yes. Okay. So Aisha, how many atoms are there that is making this void, Aisha? How many
8.
black atoms? 8, na? So coordination number is the number of atoms that make the void. So coordination number will be equal to 8.
8.
It will be equal to 8. Now, next void. Okay, moving on to the next void. So in 2D, 2 voids, 3D, there are 3 voids. Again, I have to make spheres. We have this 4. Okay, we have this 4. And I will place a atom on top of it. On top of these 4, I will place an atom. Okay. And also in the below, I will place one atom. So what you can do, you can imagine that there are these 4 atoms which are held in the air by 4 different people, and I am taking 2 different footballs. I am placing one on the top and I am placing one from the below, and between we have 4. So we are sandwiching the black ones, and on the top we have red, and on the below we have, the red ones. So this red one and this on the top is coming like this, and this red one from the below is also coming like this. So if you see the shape, it will be something like this. There will be atoms here, 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 and here, and the red atoms is above, the red atom is below. And what do you think? What is the shape? What is this shape, guys? If you remember?
Octahedron.
Yeah, correct. This is octahedral shape, right? The red one is here, the top, and in the below. I hope all of you can see that this is a octahedral void. Yes. So what will be the coordination number? Tell me in chat. What will be the coordination number? Shravya is correct. What will be the coordination number? Yes, correct. All of you are correct. It will be 6. Okay, it will be 6. Now, I want to show you a different side of octahedral void. A different side of octahedral void. And if you have learned chemical bonding with me, so let me see. Some of you must and there will be octahedral. And I must have said something about the octahedral shape somewhere. This is octahedral. Okay. Okay, not in this class. Okay, not here. Okay, fine. Let me show you now then. Where's your best? Okay. Yeah. Fine. Let me show you now. Okay. Can you see this? Tell me yes or no.
Yes, sir.
Yes, sir.
All of you can see, right? This is octahedral. The red one and the blue ones are the atoms. The yellow one, you can assume that it is a void, correct? Yes or no? Tell me.
Yes,
Aisha,
sir.
Khalid,
Yes, sir.
right? Okay. So this is a normal shape that you have already seen many times, like 4 atoms in the one plane, one on the top, one in the below, one on the top, one in the below. Now let me just change the orientation and show you guys a different view. Can you see red atoms which are behind the screen? They're making a triangle, an upward triangle, yes or no? The red atoms.
Yes, sir.
All of you can see the red atoms making an upward triangle, and they are they are behind the plane. They are behind the plane. The blue atoms, they are coming out of the plane, and they are also making a triangle, but this triangle is a downward triangle. Yes or no? Yes or no, guys? Tell me. All of you can see that the blue atoms is making also a
Yes,
triangle,
sir.
right? So this is also one of the shapes or one of the view of. Let me just copy this and I will paste it here. Here, one note. Okay, so also octahedral. So how will you view this? These red atoms is making one triangle, an upward triangle. Then these are behind the plane. And then you have the blue ones, which are above the plane, and they are also making a triangle. And this is a downward triangle. This is a downward triangle. Okay. So if you have a blue layer, it is making a triangle like this, 3 atoms, and then you have the blue atoms also making a triangle. So this is also an octahedral void. Okay, so one layer is making an upward triangle, and the layer above it is making a downward triangle. Okay, or it can be vice versa also. The below layer, it can make an upward downward triangle. The above layer will make a upward triangle, that is also an octahedral void. Can you remember this? Yes or no? If you see this type of arrangement, it will be an octahedral void. Yes or no? Tell me. Can you remember this?
Yes, sir.
Yes.
Anna, please remember this. Okay, a upward arrow, a downward arrow, upward arrow and downward arrow. So these are all the voids. Okay, these are all the voids. In 2D, we have 3 voids. How do we name the voids? We name the voids by joining the midpoints of the atoms that is making the void. And coordination number is the number of atoms that is making the void. That is equal to the coordination number of that particular void. Okay, this is all about the voids. Now we are going to start study about solid. Now, whenever you are going to start to study about anything, there are 2 ways. There is a make way, and there is a break way. Okay. If you want to study about a house, then what you can do, you can also go to a demolishing site where the house is getting demolished very slowly. And you can see that, okay, fine. When the wall has been destroyed, you can see, oh, wiring niche se tha. Okay, there was wiring, there were wires, but they were inside. Okay, then you can also see the structure, how the wires are going, how the plumbing is done and everything. And the other part, the other way that you can know how a house is built is by looking at a construction site. You go there, you see that, okay, fine. First of all, we dig some foundation, we dig some holes in the ground, we lay those iron rods, those are the pillars, then we lay the beams, and then there's concrete and everything. So you can either make something or break something. There are 2 ways. So when we are going to start to study about solid, we will be starting with the make way. Okay, so we will be making solid, we will be making solid, and this will be very much similar. This will be very much similar on how you have studied solids in mathematics, that is 3D shapes in mathematics. Okay, so we start with 1D. We start with very simple thing, we start with 1D. You can also start with 0D. If you talk about 0D in mathematics, this point is 0 dimensional. Yes or no? Correct, guys? This point is 0D. Yes or no? This does not have any dimension.
Yes, sir.
Right? And if you want to make 1D, then you join a lot of these 0Ds. You'll make a line. And this is 1D, correct? Yes or no?
Yes, sir.
And this is 1D. Now, if you want to make 2D, you take this 1D line, you take another 1D line and then join them. Now, this is 2D. Yes or no? Right?
Yes, sir.
Now, what do you do?
Yes, sir.
If you want to study 3D, you take a 2D structure, you take 2 structures which are 2D, and then you join them. And now you are studying about 3D. Correct?
Yes, sir.
Then, if you want to study about 4D structures, you take 2 3D structures and then you join them. And then so this is how mathematicians, they study the 4D structures also. They study n-dimensional structures also. Okay, they study n-dimensional structures also. So this is a way you can study higher dimensions, even if you don't have the ways in real life. You can only see 3D things, but you can study about many n-dimensional things also. Okay, you start with 0D, you take 2 0Ds and you make 1D. Then you take 2 1D structures, join them, you make 2D. And you take 2 2Ds, join them, you will make 3D. You take 2 3Ds, you join them, you will make 4D. Similarly, 5D and so on. Okay, so start with 1D structure. You will start with 1D. So 1 dimensional. And when we are taking atoms, now you'll be dealing with atoms. We'll not be dealing with points. We'll be dealing with atoms. We'll take one atom, and what we will do, we will take one atom, and I will ask that if I want to make a 1-dimensional structure, then there can be only one way in which the other atoms can come and it can join this atom to make a solid. To make a solid, we need more than one structure. Okay, we need more than one structure. So what I will do, I will take this atom and I will bring another atoms and I will join them like this. So this is 1D, yes or no? This is like a line only, correct? This is 1D structure.
Yes, sir.
And what are we doing? We are packing it, right? We are packing the atoms. So that is why it is known as 1D packing. It's known as 1D packing. Okay. So 1D packing is very simple. There is only one question that can come. NCERT has given it. So I'm stating it. Now, you all know what is coordination number, right? Coordination number is how many atoms are touching, whether it is void or it is an atom. So when we talk about packings, we will talk about the coordination number of atoms. We will talk about the coordination number of atoms that is inside the packet. Atoms that is inside the packet. So what do you think? If I take this atom, if I take one of any of these atoms, okay, I'm taking any of these atoms, what is its coordination number? Any one of these atoms is touching how many other atoms? One atom is touching how many other atoms here? Tell me.
So if you're taking one atom on its own, are you asking the coordination number for that?
Yeah, if I'm taking this atom, then this atom is touching how many more atoms?
Two.
Two, na? All of you, yes or no? Coordination number will be, yeah. Corners is not taken because this corner is not completely, its environment is not completely made, right? I can add more atoms here. I can add more atoms here, right? So whenever we are talking about packings, and whenever we are talking about coordination number of atoms, we talk about those atoms whose environment has been completely made. So if I take these atoms, which I'm marking, so I cannot add more atoms, right? I cannot add atoms on the top because it will be now 2D. We have to go only 1D. So in one dimensional, I have covered all the things in those marked atoms. But if I talk about this atom, which I'm crossing, so these corner ones, their environment has not completely been made because I can still add an atom here. So once I have added an atom here, its environment is now completely made. Okay. So when we talk about coordination number, if anyone is asking about coordination number of an atom, they're asking about those atoms whose environment has been completely made. Whose environment has been completely made. So this is all about the 1D pack. It's all about the 1D pack. Now, when I want to make a 2D pack, okay, I want to go from 1D to 2D. Now I have two choices. I can either place the atom just below the atom, correct? Or I can place it in this depression. Yes or no? I have choices. I have two choices, right? Yes or
Yes.
no? Anna? Now we are 2D. 1D ho gaya. Then we have now 2D. So in 2D, I can either put the atom under atom, or I can put atom under the depression. Okay, under the depression. So now when I go to 2D, I have two things. Two-dimensional packing. Two-dimensional packing. So one thing, did you guys write about voids? Yes or no?
Yes, sir.
All of you have written about
Yes, sir.
voids? Yes, okay, okay, fine. Now 2D packing. Atoms under atom, and other choices atom under depression. Okay, atoms under depression. Okay, atoms under depression. So how will it look? Atoms under atoms and atoms under depression. So let me start by making a atom like this, copy pasting it a few times. So I hope you can see some void, right? All of these are points now. So can you see a void? What kind of void can you
Yes,
see?
sir.
What kind of void? Tell me. What is the void here? Okay, I heard square, please.
Rectangles. So how
Rectangle,
is it
square.
square?
Who is asking? Shravya,
No,
are
sir,
you
I
asking?
meant how is square? Because it does not have definite number of atoms,
Sorry,
both
what did you
length and
say?
breadth. Sir, I meant how is it square? Shouldn't
What
it
is
be rectangle?
no? What is square? The
So
void.
it should have definite. Okay, sir.
No. Okay, so okay, fine. I understand. You're talking about this. You're saying that this is a rectangle.
Yes, sir.
No. So we are just taking a part of a solid, na? Correct?
Okay, sir.
है ना? I'm just taking a part of solid. You don't have to worry about that. You just see what kind of void is there. So you see that this void, na? So what is this void?
Yes, sir. Square, planar.
Square plane, na? Square plane void. You just have to identify that. Okay, square plane.
Yes, sir.
Square plane void. Okay. Now the coordination number of atom. Okay. So if I take this atom, I have to take the atom which is environment is complete, right? So this atom. This atom is touching how many more atoms? 4 more atoms, right? So the coordination number of the atom is how much? 4, correct? Yes or no? Any doubt till here? Any doubt till here, guys?
No, sir.
No? Okay, fine. Now we will name this packing. Okay, we'll name this packing. Atoms under atoms, it is not a very good name, right? We will not say that we are talking about atoms under atom packing. So I will name this layer A. Okay, and since this first layer and the second layer, they are indistinguishable. I cannot differentiate between them. Both of them are completely same atoms, right? And the same type of arrangement also. So this will also be named as A. So will be also named as A. So all of these layers are what? AA. It's also known as AAA type packing. Okay, any doubt till here, guys? Any doubts still here?
Sir, can you explain the AA type packing again?
Okay, fine. So I'm talking about the layers. Okay, so this is the top layer, one layer, second layer, third layer. You can understand that? Yes or no?
Yes.
Okay. Now tell me, will there be any layers? I'm taking a part of a solid. Right? Please understand that. Will there be any layer above this? Yes or no? Will be some layer above this now? Right?
Your voice is breaking.
Or
I
no?
don't know if it's there for everyone.
My voice is breaking. My voice is breaking for everyone.
Yes, sir.
Oh my God, really sorry. You have to tell it. अभी start हुआ क्या? या फिर it was breaking for a very long time?
No, sir. Now.
Now only. Now it is fine. Better.
Yes, sir.
Okay. So Atif, I am asking, will you have another layers? Na, you will have other layers above it, like, right? Yes or no?
Yes, sir.
Right. And you will have some more layers below this because we are taking a part of a solid. Okay. We'll have more layers below this, right?
Yes, sir.
Okay. Now all of these layers are indistinguishable, right? Can you distinguish that which is which layer? Yes or no?
No, sir.
No, no. All of them are same, completely same.
Yes, sir.
Is anyone having like this is first layer, this is second layer, this is third layer? You can see that first layer, second layer, third layer, but all of the
Say
atoms
voice is
and
still
the arrangement
breaking.
of atoms are complete.
Sir, now your voice is breaking a lot, like severely breaking.
Yes, sir.
Why is it happening now? My internet connection is unstable. Okay. Okay. Any I don't think so. Yes, guys, tell me. It is still the same.
Yes, sir.
Yes, sir.
I will be back in 5 minutes. Okay.
Okay, sir. Take
Give
it.
me some time. Okay. Okay, fine. Tell me now. Any better?
Right.
Am I audible fine? Yes, Atif, Aisha, Maimuna.
Yes, sir. Now it's fine.
Now it is fine.
Yes, sir.
Yes.
Okay, fine. So Atif, you were talking about AA type packing. Is it clear why it is AA type packing?
Yes, sir. It's clear.
That's clear. Okay, fine. So now let us talk about the atoms under depression. What will happen if I put atoms under the depression? So I've taken some atoms. Let me clear this dash part. Let me place them under depression like this. So what kind of void can you see? Tell me what kind of voids?
Triangular void.
Triangular void, correct. So atoms under depression, they have triangular voids. Okay, and we will also name it. Okay, we'll also name it. So for naming, as you can see, I will start with this as layer A, and the second layer is different, right? Because it's arrangement. It is a split. It is a bit shifted, right? The B one. So this is B, but this first and third, these are just same. I mean, there's no distinction between them. So this is again A, and this B, and this is also a B, right? So this will be AB type packing. Correct? Any doubt till here? Tell me. Any doubts till here?
No, sir.
No. Okay.
No, sir.
Now you tell me, if I take this atom, its environment has been completely made, and it is touching how many atoms? 1, 2, 3, 4, 5, and 6 atoms. Correct?
Yes.
So the void is triangular, and the coordination number of atom is 6. Okay, coordination number of atom is 6. So just write these things down. Then I will introduce you to one more concept.
Sir, triangular. I can't find it.
What triangle you can't find?
Like triangle word, I'm seeing an octagon here.
Okay. Oh, this is void. Now these are the voids. Yes.
Yeah.
Can you see now?
Yeah, but then it's touching 6 also.
What? Simplest, na? You start with simple things, right? You design things, you should know that you should start with simple patterns, and simple patterns lead to complex patterns, right?
Yeah.
Hana? So the simplest thing that you can say about this void, all of these voids are triangular voids, right? If I see any void, I can see that, okay, fine, these are this void. One void is made by 3 atoms, correct? Is there any void which is made by
Yes.
6 atoms? Tell me.
Sir, so the coordination number should also be 3, right?
No. Why? Coordination number of atom. Coordination. First of all, you think about coordination. Okay. Coordination number is what? How many atom is touching? Now what? How many atoms is touching an atom? Okay. Earlier we were talking about coordination number of the voids. So we asked how many atoms is the void touching. Now we are asking coordination number of the atom in ABAB type packing and in AA type packing. See, the coordination number of atom is what? 6. Can you see that, Aisha?
Yes, sir.
Is that clear?
Yes,
है
sir.
ना? So सवाल पे देखिए, like you see the question, it is about atoms. Okay, coordination number of atom is 6. And Salman, you're also clear about triangular void?
Yeah, I just got quite confused now. It's okay.
Okay, fine, no problem. Write this down. If you want me to scroll up for 1D void, you can also tell me. I will scroll up. Or if you have not read, sorry, if you want to talk about 1D packing, okay, you have to write about 1D packing. Yes, Ravi is done. Salman is done. Waiting for others. Please write this down. Let me know if you're done. Mona is done. You can just raise your hand if you're done. Okay. Okay. Aisha is also done. Waiting for Atif and Khalid. Okay, just waiting for Khalid now. Khalid sometimes gets disconnected. Khalid, you're here, right? Yes,
Yes,
Khalid.
sir. Yes, yes,
Okay.
I'm here.
Okay, okay. Just let me know if you're done. Yeah, there is no void. There is no 1D void now. You have not studied 1D void, right? So there is no void. Done, guys, all of you? Yes or no?
Yes.
Okay. Now, the next thing is, so whenever we start to talk about packing and whenever we start to talk about solid, so if I have a big solid now, so I will not be studying the whole solid. Okay. What I can study a small part of it. If I repeat this part small part will make the whole solid. So if I study the arrangement, the properties of that small part on whose repetition we get the complete solid, then we are somehow studying the solid itself. So what we will do, we'll start to study about small parts of a particular solid. Okay, small parts of a particular solid. So when I am talking about the AAA type packing, I will not study the whole packing. I will choose a particular pattern, a particular arrangement of atoms on whose repetition I can create the whole AAA type packing. I can create a whole AAA type packing. So if I look at some of the, if I take this part, let me say, if I take this small part of this AAA type arrangement, oops, wait a second. Yeah. So I'm taking this small part. And if I repeat this red part, okay, if I take this red part and if I repeat it all over, okay, if I repeat it all over the space, I will copy this, I will paste here, I will copy this, I will paste here, I will copy this, paste here and here. I can get the whole AAA type packing. Yes or no? Tell me. Can you see that happening?
Yes, sir.
Similarly, I can also take some other shape. I can take this shape also. Right? If I take this shape and I copy paste it all over the place, I will get the AAA type packing. Yes or no?
Yes, sir.
Yes.
Right? So there are many shapes that I can take. Okay, there are many shapes that I can take, and these small parts or arrangement of atoms on whose repetition or at regular intervals we get the whole packing. These are known as unit cell. Okay, so a simple definition I will write now for unit cell is arrangement of atoms that on whose repetition we get the whole packing. Okay, but we will take a unit cell which also tells me about the coordination number, because AAA type packing has a very special coordination number, that is 4. EBAB type packing has a very special coordination number, which is 6. So taking that in consideration, I will take this particular unit cell. Okay, this may look weird, but there is a reason, and the reason is that if I take this unit cell and if I copy paste all over the place, I will get the array. That's correct. This is unit cell. But what is so special about this unit cell? It is that I can also see the coordination number in this unit cell. That the coordination number is 4 for this unit cell, and that is why this is a AAA type packing. AAA type packing. And here what I will do, here I will take this type of arrangement. So here you can see that I have made a hexagonal. Here I have made a hexagonal unit cell, and this hexagonal unit cell is also giving me the information about the coordination number of the packing coordination number of the packing. So whenever, as soon as I see that, oh, coordination number is 6, it is ABAB type packing. So this unit cell is giving me all the information. Okay, it is giving me all the information. I can also see the triangular void. I can also see the coordination number. And coordination number of atoms gives you the most important information about the packing. Okay, so AAA type packing has coordination number 4. The unit cell is square, and here the unit cell is hexagonal. The unit cell, it is square, and here the unit cell is hexagonal. Okay, so please tell me, guys, is this clear with everyone? Yes or no? All of this?
Yes, sir.
Yes, that's
Okay.
clear.
Yes,
If you want
sir.
to, okay, so if you want to write this down, please write it down. Unit cell you have to write square and hexagonal. Other things you already know. Okay, so you will get an assignment, and other than assignment, what you have to do is read all the questions. Of solid state. NCERT. Okay, so initially, I mean, this is something that I think I have told the 11th standard student also when we started 11th standard, that when you read a textbook now, so the way of reading a textbook is not the same way as you read novels. So you read novel from start to end, but when you read textbook, the order has to be something different. You start with the questions, okay? Because at the end you have to solve questions when you're reading a textbook. That is the skill that you have to conquer, that you have to answer questions. What first thing that you have to do is you read all the questions. Okay, you read all the questions of a particular chapter. So when you have read all the questions, now what will happen? You know the questions, and then when you are reading the text or the theory part, you will identify, oh fine, this is the answer of that question. Okay, this is fine, this is the answer of that question. When you look at diagrams, you can associate those diagrams with those questions that you have already learned, right? So start with the questions of NCERT, read all the questions. So whenever I am teaching, in your head there must be, okay fine, एक सवाल था यहाँ से, okay fine, एक यहाँ से सवाल था, okay. So please read all the question, and you will also be given the assignment. Those who have not registered themselves in the app, register yourself, or if you don't get the assignment, just ask Nishkar sir. That is the Learnivio number that you already have. Okay. So raise your hand if you're done till now. Raise your hand if you're done till now. Okay, everyone is done. Any doubts still here, guys? Khalid, Atif, Aisha, Maimuna, Salman, Shravya.
No, sir.
No, sir.
No doubt till here. No doubts. Okay, thanks. So what did we study? We studied a few things. Okay, we studied a few things today. The first thing that we studied was about a cube. So about a cube, we studied about the corners are 8. There are how many edges? There are 12 edges, and there are how many faces? There are 6 faces. And the new thing that you studied was diagonal. Okay, so there are 2 types of diagonal. There is face diagonal, and there is also a body diagonal. And there are how many face diagonal? There are 12 face diagonal. Each face has 2 diagonals and 12. And body diagonal, there are 8 corners in the cube's body. So there will be 4 body diagonals. And the length of face diagonal for a cube whose edge length is A, if the edge length of a cube is A, then face diagonal will be A root 2, body diagonal will be A root 3. Okay. Then we started to study about void. We studied 2D void and 3D void. How many 2D voids are there? Tell me. And how many 3D voids are there? How many 2D?
2.
How many 2D voids are there? 2. We
Two.
have triangular, and the second one is square planar, correct? Yes or no?
Yes.
Yes, sir.
Triangular void has coordination number 3, and this has the void's coordination number is 4 here. Then in 3D we have, first of all, the tetrahedral void, okay, the TD void. Tetrahedral void, it has coordination number which is equal to 4. Second, what is the second one? Cubical,
void.
right?
Octa
Cubical void. Cubical void. Cubical void means what is the coordination number of this void?
8.
8.
8. And the third thing that we studied was the
Octahedral void.
octahedral. Octahedral void. So octahedral void, what is the coordination number?
6.
6. Also, one way to remember octahedral void is upward arrow and downward arrow. Okay, sorry, upward triangle and downward triangle. This is also a octahedral void, upward triangle and a downward triangle. Then after that, we studied about packings. We studied about two packings till now, 1D packing. And 1D packing, there's only one thing that you have to remember, that coordination number is 2. Then we studied about 2D packing. So in 2D packing, we have two types. We have atoms under atoms, and we have atoms under depression. So atoms under atoms, what is the name of this packing? Atoms under atoms. See your notebook and tell me what is the name.
Packing.
Yeah,
type
AA
packing.
Yeah, AA type packing. What about atoms under depression? I am not seeing the voices. I'm not
AB.
hearing the voices of others. AB.
AB.
Aisha, you have written these things now.
Yes, sir.
Please answer then. Okay, Aisha, tell me what is the void in AA type? What is the void, Aisha, in the AA type? Look and tell in your notebook.
A square planar.
Very good, square planar. What is the coordination number of the atom in AA type?
4.
4. Very good. And in ABAB type, what is the void, guys? All of you tell me. What is the void in ABAB type?
Triangular.
Triangular.
Triangular void.
Triangular void. Very good. What is the coordination